This video is for Chapter 10 of the DCAF V1 training syllabus. Chapter 10 of the DCAF V1 training syllabus satisfies Virtual Military Aviation Authority V1 Objective 1.5. The contents of this chapter include an overview of the importance of VMC minima, VMC minima within the MATZ, and how to read METARS. The aims of this video are that by the end of the video, the viewer will be able to understand safe flying practices, to know the weather conditions that may preclude visual flight, and to know how to read METARS using the METAR reading guide. So why is it important for safe flying to have minimums for weather? So VMC stands for Visual Meteorological Conditions. This means that to fly in them, you must be able to see where you are going. So why is it important that we're able to see where we're going? Well, if you're an inexperienced pilot, or if your aircraft does not have sufficient instrument capabilities, it's really important that you're able to see the runway during takeoff and landing. It's really important that you are able to see other aircraft, both on the ground and in the air, and most importantly, within the visual circuit. It's important that you are able to see and avoid cloud, as aircraft flying on instrument conditions and other hazards may be hidden within the cloud, or just past it. It's important that we're able to see and avoid dangers such as ice, which may build up on the ground, on your aircraft, or sometimes in certain types of clouds. It's also important that we do not fly in conditions where ice may severely affect our aircraft, or conditions where lightning may severely affect our aircraft. The principle of visual flying is see and avoid, and we'll investigate this principle further in Chapter 11. So what are the VMC minima that are required for flying within the visual circuit? Firstly, we must have a horizontal visibility of at least 10 kilometers. That's approximately 5 miles. The vertical distance from any cloud should always be 500 feet above circuit height. Circuit height for military aerodromes is typically 1,000 feet above ground level, although this can sometimes be changed due to limiting factors such as terrain and sharing the airspace with aircraft that have different requirements. It's important to maintain this distance from cloud in order to avoid sudden lightning strikes if they suddenly appear, to avoid ice and other dangers. It's also important that this cloud is at least 500 feet above you so that you can safely fly below the upper limit of the airspace. In uncontrolled airspace, civilian aircraft may choose to cross through the military air traffic zone. The military visual circuit is contained within the air traffic zone. By maintaining a circuit height of 1,000 feet and a minimum cloud layer of 1,500 feet, aircraft that are passing overhead at 3,000 feet are safely out of way and do not pose a threat to those in the visual circuit. So where do we find and how do we read a METAR for the mission we're about to fly? Well, if you have access to our Moodle site, which you will do if you are watching this video, simply go to Establishment and then to Operations Briefing. Within the Operations Briefing, as seen here, there is a tab for the weather. Here you can access the METAR for the mission you're about to fly. I'll briefly go through how to read this METAR now. In the top left we have the time local, denoted by time brackets L. In this case it is 1400 hours, 2 o'clock in the afternoon. On the right hand side at the top we have time Zulu, denoted by time bracket Z. In this case, that time is 1700. The top left tells you what time to expect in mission, and the top right tells you what time the METAR is correct for. Below this we have the METAR in code. I'll read them as blocks, so the first block, the 4-letter code, is an Aerodrome International Civilian Aviation Authority code. The following block is the surface wind. The following block is the surface visibility in meters. The following block is cloud. The following block is further cloud. The following block of two numbers followed by a forward slash followed by two numbers is temperature and then dew point, respectively. The following block is the pressure in hectopascals or millibars. The following block denotes any significant changes. So the first four letters, UGKO, Uniform Golf Kilo Oscar. Uniform Golf tells us that this is Georgia. Kilo Oscar tells us the aerodrome, in this case, Kutaisi. Now for the wind block. The first three numbers are always the direction the wind is blowing from. The following two, or in some cases three, numbers is the wind strength. So in this case we have a wind from 250, which is a roughly west-southwest direction, at a speed of 0.9 knots. KT indicating the unit of measure. In some cases you may have the number for the strength, followed by a G, which will indicate gusts, followed by another two numbers, which may indicate the strengths of the gusts. This means, for example, if we have 250.09 Golf 19, that we have a wind from 250 degrees with a minimum strength of 9 knots and a maximum gust of 19 knots. In some cases, we may have a code such as 250.09 Victor. This means that the wind is from 250 and it is blowing at a strength of 0.9 knots, but it is variable in direction and strength. The following four numbers, the horizontal visibility in meters, say 9999. This may mean 9,999 meters to any ordinary person. However, it actually means that the surface visibility is more than 10 kilometers. In other words, it is so clear that it cannot be recorded to be any higher. The following block is the first layer of cloud. In this case, it reads Sierra Charlie Tango 022 Charlie Bravo. Sierra Charlie Tango, SCT, is an abbreviation for scattered. 022 is the height of the cloud in short form. Add two zeros to the end of this number to achieve it in long form. So 022 will remove the first zero because we don't need it, and we'll add two zeros afterwards. That height now becomes 2,200, and this is measured in feet. The following two letters, Charlie Bravo, denote that it is cumulus nimbus. This means that it is a thundercloud. Now remember, visual flight rules precludes flying in thunderous conditions. However, if you're with a competent instructor, this may be omitted for the purposes of online training. The following block is Bravo Kilo November 046. This is short form for broken clouds, and the height for this would be 4,600 feet. The following two numbers is the temperature and dew point in degrees Celsius, therefore a temperature of 24 degrees Celsius and a dew point of 21 degrees Celsius. The following block is the QNH in hectopascals and millibars. In this case we have a QNH of 1016 hectopascals. The following block, which says no sig, simply means no significant change since the last METAR. METARs are updated hourly. The winds aloft below can be read very similarly to the winds above, having both direction and magnitude in the same format as the rest of the METAR. This is not of concern to you as you will not be flying outside of the visual circuit. However, Each of these winds aloft has a height. 1600 feet MSL means 1600 feet above mean sea level. 6600 MSL means 6600 feet above mean sea level, and FL260 means at a flight level of 260 or 26,000 feet. To the right of this we have the QNH in inches of mercury, indicated by brackets INHG, India November Hotel Golf. This is for use of majority of the aircraft within DCS, which use American units of measure. In this case, the QNH is 30.00 inches of mercury. Below this we have the NOTAMs. Although this is not necessary for your stage of the training, it is important to note that anything that may affect the safety of ordinary flights will be NOTAMed here. NOTAM stands for Notices to Airmen. Now we shall look at a METAR, which shows us that we would not be permitted to fly due to the weather conditions described within the METAR. In the top left we can see the time local is 1400 hours, or 2 p.m. In the top right we can see the time in Zulu. This is 1700 hours, or 5 o'clock in the afternoon, 5 p.m. The METAR reads Uniform Golf Kilo Oscar 26006 Kilo Tango 7000 Bravo Kilo November 013 34/17 Quebec 1013 November Oscar Sierra India Golf. Pause the video now and see if you can decode that METAR. So, from left to right, the first block, Uniform Golf Kilo Oscar, is the code for the airfield. Uniform Golf meaning Georgia, Kilo Oscar meaning Kataisi. So it's Kataisi Koptari Airfield in Georgia. 26006 Kilo Tango means there is a wind from 260 degrees magnetic, blowing at a strength of 06 knots, or 6 knots. The next block means that the horizontal visibility is 7,000 meters. The next block means that there is a cloud layer broken, so that is between 4 and 8 octaves, at a height of 013. Add 2 zeros onto the end of this, and that means that the cloud is at a height of 1,300 feet above ground level. 34/17 is the temperature and dew point respectively in degrees Celsius, so 34 degrees Celsius for the temperature, 17 degrees Celsius for the dew point. Quebec 1013 is the QNH of the region in hectopascals. No SIG, November Oscar Sierra India Golf, simply means no significant change between this METAR and the METAR issued an hour ago. So why would this METAR preclude us from flying? Well, if you're ever confused about this, simply follow the meteorological condition guide, highlighted in blue below the METAR. We need a visibility of 10,000 meters or more. So, the METAR should either say CAVOC, Charlie Alpha Victor Oscar Kilo, or it should say 9999 for 9,999 meters. This means that the visibility is 10 kilometers or more. The lowest the cloud can also be is 500 feet above circuit height. Circuit height is 1,000 feet above ground level. Therefore, the lowest the cloud may be is 1,500 feet. Here, the cloud is 1,300 feet. That is only 300 feet above circuit height. If either of these conditions do not meet the minimum requirements, you may not be able to fly. For example, if we had a visibility of 10 kilometers, but the cloud remained at 1,300 feet, you would not be able to fly because the cloud base is not high enough. If the cloud base was at 1,500 feet or more, but the surface visibility was 7,000 meters, you would not be able to fly because the horizontal visibility is not great enough.